Now that we've studied ARIMA models and we've understood some of their features, it is time to revert our attention to estimating these and how do we select the actual orders of the autoregressive components or the moving average components and so on. So first to estimation, let's assume that we've got some identified order, some PDQ. We want to estimate the parameters of that model. Now they may or may not include a constant, but we'll have some autoregressive parameters and some moving average parameters. The way we estimate the models is using maximum likelihood estimation, which is quite similar to least squares. We introduced this in ETS. So remember that in maximum likelihood estimation, we want to maximize the probability of obtaining the data that we've observed from the model. Okay. The ARIMA function actually allows for both conditional least squares and maximum likelihood estimation. If you want something quicker, you might revert to conditional least squares. The actual default is maximum likelihood estimation. Now we need to use nonlinear optimization. If you think about the structure of the model, you have lags of y's and you have lags of your errors on the right hand side. So you need to use some nonlinear process to actually estimate these and some conditioning as well. So in ARIMA and in the Fable package, we use the optim function and to find the values of the parameters. The other thing to note here is that different software may give you different estimates. They shouldn't vary too much, but they will be different, and that's mainly for a couple of reasons. One is that different software might be looking at optimizing different criteria. So some might be doing least squares, conditional least squares. Some might be doing maximum likelihood. Some might be doing full maximum likelihood versus conditional maximum likelihood, and so on. The second reason is that different packages use different optimizers, and different optimizers deal with some situations differently. We have starting values that might play a role. You can also have different optimizers falling into local minima rather than a global minimum, so that you may get some discrepancy. Now, what we do in R, I believe, is as good as it gets in terms of optimization. Now the question becomes, okay, we have we know how to estimate a model with some order PDQ. If I have several of these models, how do I choose between them? Well, we're going to revert back to model selection criteria that we did for the ETS models as well, and we're going to use the usual criteria. So archaic is an information criterion where it's defined as -2 times the log likelihood plus the penalty term, 2 times the number of parameters in the model. So the number of parameters in the model are P for the autoregressive part, Q for the MA part, K is 1 if we include a constant, or 0 if we don't include a constant, and we also have 1 for the variance estimate. We also have the corrected version for small samples here, the corrected AIC. And this is, and we also have the Bayesian information criteria, which is used. And as we mentioned before, Bayesian information criteria was written for different reasons and is good for different reasons. So in forecasting, our preference would be to use the AIC. In fact, the default setting in what follows next in terms of how we select models is the AICC.